Either you give him one.
So you just screech. Ow.
Yeah. And he's all pumped up.
Okay, when you have a point, so I'm giving you a point, I moved 5 to the left, down 6. This is how you draw every one of your triangles. The vertical line will be the perpendicular back to the x-axis. So you'll always go perpendicular to the x-axis. From now on, whenever you do these triangles, your vertical line will always be perpendicular to the x-axis, right? That's where your right triangle will sit. The terminal side will go from the origin out to the point. And then theta sits there. So you'll hear me say it over and over and over. Just draw a terminal side in the quadrant. I don't really care where the terminal side is located. Theta always sits between the x-axis and the terminal side. Theta always sits between the terminal side and the x-axis. And your perpendicular goes from the point back vertically to the x-axis. So if you're above it, you just come down to the x-axis. If you're below it, you come up. That's a standard variable in trig. So it's the same thing. You guys grow up when you do your algebra. Why do we always use x and y? It's just kind of a traditional algebraic variable. Theta is the traditional trigonometric variable. I could use any letter I want, like big A, big B, big C type of things. But in trigonometry, for whatever reason, we use Greek letters. So theta is the traditional one. It's on your calculator when you go into trig mode stuff. Because theta represents an angle. So right now, remember, it's representing the angle. No, theta could be 30 degrees, could be 29 degrees, could be 18 degrees. It represents an angle, yes, angle measure that we don't know yet. Yep. Yes, your terminal side in all of these really is your hypotenuse. Yep. So if I label this triangle, I went 5 to the left, I went down 6. So there's your sides of the triangle. What's your hypotenuse? You square the two legs and add them up. So 36 plus 25 is square root of 61. So that's my hypotenuse. Please write down the 6 trig functions. Write down your 6 trig functions. I'm going to load up the answer key and then we'll check what you have. So we had set up our triangle, and what you can see with your sine, cosine, tangent, the red number is exactly what you'd get off of your triangle. In green here, that's your sneaky form of 1 to help rationalize the denominator. So our final answers are written in blue. So you should look at the blue stuff. And then when you go to write the reciprocals, instead of writing the reciprocals of the blue ones and then have to rationalize again, just go back to here, right, and flip that one. So hopefully that was good. Most of the time we'll ask you, you can get a little sick of it, but all 6 trig functions get written down. When you get to the exam, then we might just ask for one of the 6. But
I like to eat tons of it.
Maybe somewhere along the way a teacher has taught you the 45, 45, 90 or the 30, 60, 90 triangle. Yes?
Oh yeah.
It does help to have it memorized. I mean, there's something about having it memorized and being able to just quickly go through the relationship. But for instance, let's start with the 30, 60, 90 triangle. If I take a triangle, you know, that's 60, 60, 60, and I say my sides are maybe 6, 6, and 6. What happens when I split this triangle? I draw the perpendicular bisector. Now, not in all triangles, when you draw the perpendicular bisector, does it bisect all angles and all sides, right? I mean, but in this case, it was an equilateral triangle that I did. So can you tell me what this side is right here, this x? How much is that? Because I cut it in half, right? Now, could you find this length? Yeah, x would be equal to the square root of 6 squared minus 3 squared, right? 36 minus 9 is what? 27. 27 can be written as 9 times 3. Which one of those numbers can you take the square root of?
9.
So that's 3 root 3. So the relationship is, if you have a 30-60 triangle, the side opposite the 90 is the largest side. The side by the way, what would this angle be right here?
30.
30. The side opposite the 30 is the hypotenuse cut in half, right?
Yeah.
And then the shortcut that a teacher probably taught you is the side opposite the 60, all you do is multiply the short side by root 3. And then you can work it the other direction too. But even if you didn't have it memorized, I could draw a picture just like we did. I could cut the equilateral in half and figure it out myself without having to memorize anything. I just know how to work with the figure. So the same thing can happen with a 45, 45, 90 triangle. You can go through the exact same information. But the idea is, when you look at the relationship, this is what we call an isosceles right triangle. Two sides are the same, right? When you go from the legs to the hypotenuse, you multiply by root 2. What do you do when you go backwards? You divide by root 2. So you either multiply by root 2 to get to the hypotenuse, or you divide by root 2 to get back to one of the legs. So these two triangles right here are the relationships that maybe might help you if you memorize them, or at least know how to figure them out. You can do it all by drawing a right triangle and just picking something to be the side, and then use your geometry and some of your algebra. Here's the work we're going to do. We're going to assume that the hypotenuse is 1. So on a 45, 45, 90, the isosceles right, I'm going to put a 1 there. So if you look at the relationship up above, if you know the legs, you multiply by root 2 to get to the hypotenuse. Well, now we know the hypotenuse. So what do we do to get back? Divide. So we need to know, what is 1 divided by root 2? Are we allowed to leave it like that? No, we rationalize. Root 2 over root 2. So what do you get? 1 times root 2 on top is root 2. Root 2 times root 2 on the bottom is root 4 or 2. So the missing sides then are root 2 over 2, root 2 over 2. You know the legs, you multiply by root 2 to get to the hypotenuse. If you know the hypotenuse, you divide by root 2 to get back. 30, 60, 90. If I tell you that the hypotenuse is 1, remember the 30, 60, 90 comes from the equilateral. If you visualize, a 1 by 1 by 1 triangle, if the hypotenuse is 1 and I cut the triangle in half, what's the short side? Half. You cut the hypotenuse in half. And when you go from that short side to the larger of the two legs, you multiply by what? Root 3. What is root 3 times 1 over 2? Well, it's just root 3 over 2. That's really the last time you have to use those triangles. Because everything we do, we're setting you up now for what's called the unit circle. And 45, 30, and 60-degree angles are very important mathematically. We use them a lot, and that's why we get into the unit circle stuff. Okay? I can't remember how your packets are set up. I think you guys have the table there. So I'm just redrawing it quick. 1, root 2 over 2, root 2 over 2. These are 45. And if I have a 30, 60, 90, 1, 1/2, root 3 over 2. Okay. So we're going to fill in some of the table. I won't fill in all the table, but we're going to start with sine. What is the sine of 30 degrees? So where do I get sine of 30? Which triangle do I go to? The 30, 60, 90. Go to the blue triangle. Go to 30 degrees, which is up here at the top, right? Opposite is 1/2. Hypotenuse is, so literally you have 1/2 over 1. Well, that simplifies to 1/2. What about the 45? Where are you going to get that? From this triangle. Does it matter which 45 I go to? No. So pick one of them. The opposite then is root 2 over 2. Hypotenuse 1. Well, that's root 2 over 2. 60 degrees. Where are you going? Go over to the blue triangle. 60. It's down here. Opposite, root 3 over 2, hypotenuse 1. So that's root 3 over 2. We'll do the cosine and then you can ask some questions. Cosine of 30 degrees, what do? You go to the blue triangle again. So let's go to 30 degrees, right there. Oh, right there. What's the cosine? Adjacent over hypotenuse. So that will be the root 3 over 2 divided by 1, or root 3 over 2. Go to a 45. It doesn't matter which 45 you pick. Pick that one. What's the cosine of 45? Adjacent, root 2 over 2, divided by hypotenuse 1, or square root of 2 over 2. And then finally we get to cosine, of 60 degrees. So 60 is here. The cosine is the adjacent 1/2 divided by the hypotenuse 1, or 1/2. So as you look at those numbers we're writing in, I want you to think about some relationships. What does it look like? What do you notice about that pattern? Okay. Let's do tangent together. And so I really don't need any of this stuff up here anymore. So I'm going to get rid of that. I'm just going to bump this up a little bit. To do tangent, you can certainly go opposite over hypotenuse every time. But I'm going to tell you that tangent is the sine of theta over the cosine of theta. So I really want you to get in the habit of maybe just knowing how to do that. Because in this table, I just want you to take the sine and divide by cosine. So for 30 degrees, tangent of 30. I'm going to take the sine, that's 1/2, and divide by the cosine, that's root 3 over 2. Oh, roughly about 4th or 5th grade, a teacher told you when you divide by a fraction, you do what? When you divide by a fraction, you multiplied by
Reciprocal.
the reciprocal. So this is 1/2 times 2 over root 3. The 2's can go ahead and cross off. And I'm left with 1 over root 3. What do I do with that? Rationalize, and I get root 3 on top, 3 on the bottom. So all I did is take the sine and divide by cosine, which really is to take sine and multiply by the reciprocal of cosine. Because when you divide by a fraction, you multiply by its reciprocal. 45. What do you do? Sine is root 2 over 2. Cosine is root 2 over 2. What do you get when you go? Yeah, 1, right? That's super easy. And then the last one, doing the tangent of 60 degrees. So the tangent of 60 ends up being root 3 over 2 divided by 1/2. Take your sine on top, divide by your cosine. When you divide by a fraction, you multiply by the reciprocal. So root 3 over 2 times 2 over 1. The nice thing about this, when you cross off the 2's, you're left with root 3 over 1 or root 3. Okay, so the point will be, when we get into the unit circle, I will teach you how to do sine and cosine. You'll have that memorized. That's the point of the unit circle. And then the rest of this just comes from knowing how to work with the sines and cosines that you write down. Okay, let's do, let's have you fill in these boxes. Let's have you do, that one. No, that's just that one. Just so you get used to working with them, some are easy, some are not. But just fill in those 3 boxes. If you want to work with somebody sitting next to you, go ahead. And then I will put the answers up there. Okay, if I'm going to work with the cotangent, what do? I would just go to the tangent of 30 degrees and write the reciprocal. So I'm going to write the reciprocal of this, which becomes 3 over root 3. Can I leave it 3 over root 3? No, we're going to rationalize that. I'm sorry, that's probably a little small. Too bad. Anyway, so I get 3 root 3 over 3. Right?
No.
Cross off your 3's, and your final answer should be root 3. So I write the reciprocal. So if I'm asking you to do cotangent of 30, you do the reciprocal of the tangent of 30. How do I do cosecant? How do I do the cosecant? I'm doing the secant of 45 degrees. So I'm going to bring the cosine, right? I do the reciprocal of cosine. Okay? So this is 2 over root 2. We're not allowed to leave it 2 over root 2. So we're going to rationalize. Root 2 over root 2. And I get 2 root 2 over 2. Cross them off. And my final answer is root 2. So I'm not memorizing any additional information. I'm just using what's in this table and doing reciprocal. When you work with the cosecant, it's reciprocal of what? sign. So I come up here and I grab this answer, this root 3 over 2, and bring that down here. Let's do it in purple. So that becomes 2 over root 3. I have to rationalize with the root 3 over root 3, and I get 2 root 3 over 3. You know, so when some of these, like when you look at the blue one and the red one, there are a lot of common numbers in there. We had to do some extra crossing off, but I didn't memorize anything else. It was just use the information that I already knew from the table. This we'll get all that information off the unit circle, and you guys will have that memorized, and you'll be able to fill in that table within seconds of me giving you something. That's how fast you'll have it memorized by Monday. Then the rest of that information we just slowly would fill in.